Am I audible, friends? Can anyone confirm?
Yes,
Yes, sir.
Yes, audible.
Sir.
Yes, sir,
Yes.
you are audible.
Okay, thank you. Let me welcome you all to our weekend webinar series. Let me give some brief background of this session. So every weekend, Saturday and Sunday between 8 to 9, we organize a session on either research methodology, biostatistics, or qualitative data analysis, or geographical information system. So those are tools that are applied for the research. So today's session, we are planning to start with basic concept of statistical in data science or public health. So today's speaker is Professor Rajiv Chaudhary. Currently, he is the professor and dean of students welfare, and he is a expertise in exercise physiology, research methodology, and applied statistics, yoga sciences. Dr. Chaudhary has more than 110 peer-reviewed publications and 17 books, and more than 30 book chapters. He has received the Best Teachers Education Award from NCTE, a statutory body of Government of India. He received the Professor of the Year in Social Science in 2014-15, 2015-16 from Pandit Ravi Shankar Shukla University. He received the Lifetime Achievement Award from Physical Education Foundation of India. So the basic concept is being a non-statistician, being a physical education. So let us learn the basic statistical concept from in the language of a layman. Okay, so I have associated with Professor Chaudhary since more than 10 years. He has been conducting the statistical workshop in SPSS, Tata and R across the country, and he is a well-known speaker in statistics. So let us enjoy his talk. Let me invite Professor Chaudhary to share his screen and start the presentation. Sir,
Yes, sir. Thank you, sir. Thank you very much. Am I audible?
Yes, sir, you are audible.
Thank you. At the very outset, I would like to express my sincere thanks to each and every unit of Global Center for Public Health. As we all aware that this Global Center for Public Health is organizing weekend webinar series. I think it's a 15th webinar series. I am directed by the organizers to speak on the title Basic Concept of Data Analysis. And Dr. Padhi, my friend, allotted me only 1 hour. I will try my level best to cover the contents related to different statistical tools from both the categories parametric statistics as well as non-parametric statistics. Ladies and gentlemen, one quote by eminent personality regarding the significance of research I would like to share with you. Anything without research is like shooting an arrow into the air, then looking for the target to catch it with. And to conduct true researches, to conduct reliable researches, to conduct genuine researches, especially to conduct quantitative researches, we require statistical tools and techniques to analyze data. Since we undergo several steps, we identify the problem, we formulate the hypothesis, we collect the data, and after the collection of the data, the main problem a researcher faces the application of the proper statistical tool full of statistical control to analyze the data. So I will discuss in detail about that. So without wasting time, I am going to start my presentation on the title Basic Concepts of Data Analysis. Padiji, is it visible on the full screen?
Yes, sir. It's visible.
Yes. Basic statistical concepts in data science. For better conversation, I divided my presentation into two different parts. First, I will discuss about the concept of variables. Since in quantitative researches, we conduct the researches by taking different types of variables. So I will discuss about the concept of variables, and the main part will be basic concept of statistical tools. Let's start with the first, that is concept of variables. Different authors classified variables in different forms by taking different bases. but I am going to discuss about two different types of classifications. One is on the basis of causal model, since especially in biomedical researches, there is a trend of conducting experimental studies. If any researcher, if any investigator want to conduct experimental studies, that this causal model is applicable. The classification of the causal model is applicable. On the basis of the causal model, we classify all the variables into three different categories in three different parts. First one is an independent variable. Let's formulate a hypothetical title to understand in a proper way. Let's formulate a title: Effect of drug X on Y disease. Investigators' interest is to find out the effect of drug X on Y disease. In this hypothetical example, the independent variable is a drug X that is considered as a treatment, and investigator want to find out the effect of a particular treatment that is considered as independent variable. Next one is a confounding variable. In this hypothetical example, effect of drug X on Y disease, investigators' interest is to find out the effect of only drug X on Y disease, but it never happens. There are several variables, there are several factors that play a vital role, that leave an effect. These are considered as a confounding variable. Examples are daily routine, food habits, social background, maybe heredity, maybe climatic conditions, and these confounding variables are classified into two subcategories. First one is intervening variables. By intervening variables, I mean which are beyond the control of the investigator. We cannot control, and these will be considered as our limitations. And second one is extraneous variables. This category of confounding variable, that is extraneous variable, these can be controlled to a great extent. An investigator control these variables. And the third type of variable is a dependent variable. In this hypothetical example, effect of drug X on Y disease is considered as a dependent variable. Ladies and gentlemen, we should keep in the entirety of our mind, change in dependent variable means change in. This is why only due to independent variable in this hypothetical example, only due to drug X is considered as a treatment variance, and change in dependent variable means change in Y disease other than drug X is considered as a error variance. And the principle of to conduct experimental studies, maximization of treatment variance and minimization of error variance. We have to select proper experimental design and we have to apply proper statistical tool. By using that, we can maximize the treatment variance and we can minimize the error variance. It's clear from this sentence that error variance cannot be eliminated. Only an investigator can try to minimize the error variance. Due to this reason, there is a concept of level of significance. In biomedical researches, they conduct researches at 0.0501 level of significance. That means they are 99% confident, but their significance level is 1%. After the classification of one on the basis of causal model, I will discuss about only one more classification on the basis of the unit of measurement. If we classify all the variables on the basis of the unit of measurement, we classify into four different categories. Number one is a nominal scale. The first type is a nominal scale. Nominal scale means when we collect data, when we record any unit of measurement in frequency or count, that is considered as nominal scale. For example, number of patients, number of agree, number of disagree, number of healthy, number of unhealthy. That will be a discrete series. That will be a whole number. And these are sub-classified into different categories. Nominal scale may be dichotomous. Dicho means two, having two ends. Example, smoking. If we records the responses of the smoking, that will be dichotomous in nature. We have only two options, smokers and non-smokers. Second may be polytomies. If these are classified in more than two categories, that is considered as a polytomies. For example, race. Race may be classified into different categories, maybe Chinese, Indians, Polish, Germans, Americans. And the next is ordinal scale. When we are unable to measure any data, any score in a numeric way, we have to measure in an order, maybe in ascending order, maybe in a descending order. Example is, suppose if we suffers from a jerk or a joint pain, if the doctor asks what is the severity of pain, we cannot say we have 5 centimeter pain or we have 5 kg pain. We have to express in order. We have high level of pain. So the example of the severity of pain, that is an example of the ordinal scale. We cannot make, we have to measure in order by the help of percentiles, by the help of quartiles, by the help of deciles. And the next one is interval scale. Interval scale means having same intervals in between but has no fixed zero. There is a long list of psychological variables: aggression, anxiety, stress, depression. We measure in an interval scale. And the last category, last type of the variable on the basis of unit of measurement, that is known as ratio scale. The difference between a ratio and interval scale is having same interval is in between but has a fixed zero. For example, height, weight, these are the examples. So we conduct our studies by taking different types of variables. We should have an idea. What do you mean by independent variable? What do you mean by confounding? And what do you mean by intervening, extraneous, nominal scale, ordinal scale, interval scale, ratio scale, and so on. After the brief description of the types of variables, I will proceed to the main part that Dr. Paddy assigned me, basic concept of data analysis. So I will discuss about different tools which are used, especially in biomedical researches. Not only in biomedical researches, I will discuss by taking different hypothetical examples from the field of engineering, from the field of business studies, from the field of medical sciences, education, social sciences. So for data analysis, we require statistical techniques. Ladies and gentlemen, we apply statistical tools, statistical techniques to analyze the data, but we should have an idea about the limitations of statistics. It is not possible to discuss about all limitations of statistics in the limited duration of time. I will discuss about two main limitations. First one is statistical laws are not exact. What does it mean? It means by the help of the application of statistical technique, after the analysis of data, we get the probable answer. These are not exact. And second one is statistics is liable to be misused. Few scholars, few researchers misuse intentionally, few researchers misuse unintentionally. So we should keep these two limitations in the entirety of our mind. The statistical laws are not exact and statistics is liable to be misused. And these statistical techniques are also known as inferential statistics. Why? Since we draw inferences by the application of these techniques, so these are known as inferential statistics. All the statistical techniques, all the statistical tools, or we can say that all the inferential statistics are divided into two different categories. One is parametric statistics, another is non-parametric statistics. But we always apply parametric statistics. No, it's not correct. There are some assumptions, and these assumptions should be fulfilled. Only in that condition we can apply parametric. Otherwise, we cannot generalize the results. Then the question arises in the mind of the investigator: what are the assumptions to apply parametric statistics? There are two common and main assumptions. First one is the data should be normally distributed. If the data is normally distributed, in that condition also we can apply parametric. Otherwise, we have to apply parallel non-parametric statistics. And since we all are associated with the field of research, we know the concept of normal distribution. Normal distribution means having maximum concentration of the scores at the center and the frequency tapers at both the ends. So the first step in front of the investigator is first test the normality. If this assumption is fulfilled, apply parametric. Otherwise, apply parallel non-parametric technique. Second one is parametric technique can be applied only to scales of measurements, that is interval and ratio scales. In my previous part, in my first part, I have discussed about the 4 different types of scales of measurements: nominal, ordinal, interval, ratio. Out of all 4 scales of measurements, we can apply only in interval or ratio scale. But we do not require any tool or the technique or test to test the scale of measurement. We all have enough knowledge or enough vision. We can, by seeing the nature of any variable, yes, we may decide this comes into the category of nominal scale or in the category of ordinal scale or in interval scale or in a ratio scale. On the other hand, in case of non-parametric statistics can be applied in any distribution and in any scale of measurement, in nominal, ordinal, interval, and a ratio. So first we have to test the normality. Why? We have to decide, as an investigator, we have to decide whether we have to apply parametric or non-parametric. Now we will discuss in detail how to test the normal distribution, how to test the normality. We have to check the normal distribution. There are 3 different ways by which we can test the normality. First one is descriptive statistics. Second one is graphical method. Third one is a formal test. What do you mean by descriptive statistics? We know that descriptive statistics means all measures of central tendency, that is mean, median, mode, and all measures of variability, that is range, quartile deviation, mean deviation, standard deviation, as well as skewness and kurtosis. If our objective is to test the normal distribution, then we do not require all the descriptive measures. We require only 4 descriptive measures, and these descriptive measures are skewness, standard error of skewness, kurtosis, and standard error of kurtosis. What do you mean by skewness? Means that measures the symmetricity of the curve, and kurtosis measures the flatness of the curve. The symmetricity should be there and the flatness should be optimal, and we need standard errors of both, that is skewness and kurtosis. What do you mean by standard error? Ladies and gentlemen, each and every individual is bound to have some error. The acceptable errors are known as standard errors. Same as human beings, every statistical technique is bound to have some error. The accepted error is known as a standard error. If the value of skewness is less than standard error, we can accept, yes, data is distribution, we have the normal distribution. If the value of kurtosis is less than standard error, yes, we can accept and we can apply parametric. But there is a thumb rule. If the value of skewness as well as value of kurtosis is in between -1 to 1, it means data is normally distributed. Second one is a graphical method. We know that in graph we have a x-axis, we have a y-axis. A standard line is generated by the QQ plot. QQ plot is a graphical method by that we can test the normality. A standard line is generated. All the scores should be scattered near to this line. If all the scores are scattered near to this line, it means yes, data is normally distributed. Otherwise, we have to apply parallel non-parametric technique. Third one is a formal test. Formal tests are formulated or structured only to test the normality. There is no another function of the formal test. There is a long list of formal tests, but in tradition, in use, there are 4. First one is KST. KST means Kolmogorov-Smirnov test. Second one is SWT, Shapiro-Wilk test. Third one is ADT, Anderson-Darling test. Fourth one is RJT, Rayan-Joyner test. Again, I repeat, Kolmogorov-Smirnov test, Shapiro-Wilk test, Anderson-Darling test, and Rayan-Joyner test. But we require only one test out of all of these four to test the normality. In the field of social sciences, or as well as in the field of biomedical sciences, different researchers use the software SPSS, Statistical Package for Social Science. In SPSS provide us the facility of only first two tests. There is a facility of KST, Kolmogorov-Smirnov test, and SWT, Shapiro-Wilk test. We have three methods: descriptive, graphical, and formal. So then one more sentence that is important is testing normality depends on sample size. If we talk about the earlier assumptions, there was a concept of small sample and large sample. If an investigator, if any researcher conduct the study by taking less than 30 subjects, that was considered as a small sample. If the sample size is 30 and above, that was considered as a large sample. But this concept has been changed. The concept of small sample is same. If we have less than 30 units, if our sample size is less than 30, that is considered as a small sample. If we are going to conduct any study by taking in between 30 to 100 units, if our sample size is in between 30 to 100, that is considered as a moderate sample size. If we conduct any study taking 100 and more samples, that is considered as a large sample. As I have said earlier, that testing normality depends on the sample size. It means the way of testing normality of small sample will be different. The methodology of testing moderate sample size will be different. The testing normality of the large sample will be different. We will discuss one by one. Let's start with the first, testing normality of small sample size. As per the statisticians, as per the eminent scholars, if any individual want to conduct any study by taking small sample, there is no need to test. Always assume that data is non-normal. Then directly apply non-parametric technique. Now we will discuss about the testing normality of moderate sample size. How many methods we have to test the normality? 3. Which one? Descriptive, graphical, formal. Out of all these 3 methods, first apply formal test. What will be the answer? Answer will be either normal or non-normal. If the result of the formal test is non-normal, accept the results and apply non-parametric. If the result of the formal test is yes, normal, then do not 100% rely on formal test. Apply or cross-test by remaining 2 methods, that is a descriptive, graphical. Now, how to test the normality of large sample size? The sequence will be same. First, apply formal test. If the answer of the formal test is yes, data is normally distributed, in that case, there is no need to cross-test. There is no need to cross-test. Accept the results and apply parametrics. Why? Hello? Why? The cause is these formal tests are very accurate in case of large sample, but these are very sensitive in case of moderate sample size. So, ladies and gentlemen, if the formal answer of the formal test is yes, data is non-normal, no, there is a possibility of outliers. Then check the outliers and cross-test the normality here and remove the outliers. If we remove any exceptional score in the beginning, that will not be considered as an ethical issue. If we remove any outlier or if we remove any exceptional score that distort our distribution after the analysis of data, that will be considered as an ethical issue. So ladies and gentlemen, we should take care about that. We have discussed about the methodology of testing normality. Then I will discuss about the different techniques. By applying that, we can analyze data. As I have said, we divide all the techniques, statistical tools into two categories, parametric and non-parametric. To understand in an effective way, we divide parametric statistics into two categories, that is comparative and relationship. And smallest comparison can be in between two groups. Then we can compare more than two groups. Then we compare by taking a covariate. And if we talk about the relationship statistics, the smallest relationship can be in between two variables, maybe more than two variables, maybe in between more than two variables. And if we quantify if an investigator try to quantify their relationship, then we have to apply regression. That may be a linear regression, that may be a multiple regression, that may be logistic regression, multinomial, and so on. Let's discuss one by one. See, I will start from the comparison between two groups. If any investigator want to compare two groups, the technique which is used to compare two groups is known as t-test. Actually, by the help of the t-test, by the application of t-test, we do not compare groups. T-test is a statistical technique used to find out the significant difference between the means of two samples. By the help of t-test, we compare the means of two samples. But there are three different types of t-tests. First one is known as independent t-test. The first technique is known as, the first type of t-test is known as independent t-test. This independent t-test is known by four different names. One name is in front of you, independent t-test. Another name is student's t-test. Third name is simple t-test. And this is also known as unpaired t-test. Independent t-test is used to find out the significant difference between the means of two independent groups. That's comparison of the leukocytes in between males and females. Investigator want to compare a variable named leukocytes in between whether females possess more leukocytes counts or males possesses more leukocyte counts. It means both the groups are independent in nature, but the independent t-test is used to conduct survey studies, especially comparative survey, for the comparison of two groups. And the statistical technique we are discussing about the independent t-test, and the design in which this independent t-test is used is known as static group comparison design. Next one is dependent t-test. This dependent t-test is also known by four different names: dependent t-test, paired t-test, correlated t-test, and repeated measure t-test. What was our example for independent t-test? Our example for independent t-test was comparison of the leukocytes between males and females. Let's formulate a hypothetical title for dependent t-test: effect of morning walk on blood pressure. In layman's language, investigator want to find out the effect of morning walk on the blood pressure. Independent t-test is used to conduct surveys. On the other hand, dependent t-test is used to conduct experimental studies. If any investigator want to conduct an experimental study, effect of morning walk on blood pressure, two observations will be taken by the investigator in the form of a pre and post, and in between the pre and post, treatment is given. And in this hypothetical example, treatment is morning walk. It means dependent t-test is used to find out the difference between the means of two different observations of the same group. Next one is one sample t-test. This one sample t-test is known by the single name. I didn't see another name in my life in relation to this one sample t-test. One sample t-test, please try to recall. The hypothetical example, the hypothetical title for independent t-test. Today's our hypothetical example is comparison of leukocytes between males and females. And for dependent t-test, we formulated a title, effect of morning walk on blood pressure, that comes under the category of experimental researches. And let's formulate a title. Suppose females of India wants to compare their leukocyte count with the target or a specified constant with a fixed value, with a normative value. It means one sample t-test is used to compare a group with a single value, to compare a group with a specified constant. Let's formulate comparison of the leukocyte counts of Indian females with the standard value. So we can by applying in the medical sciences, in biomedical researches, you will find the application of one sample t-test to compare a group with a specified constant, to compare a group with the normative value. So we have discussed in detail about the application of three different types of t-tests. Again, I repeat, independent t-test is used to conduct comparative surveys. Dependent t-test is used to conduct experiments, and one sample t-test is also used to conduct surveys. But the difference between the independent t-test and one sample t-test is, in independent t-test we compare two different groups, but in one sample t-test we compare a group with a fixed value. Now let's discuss about the comparison among more than two groups. The technique which is used to find out the difference between more than two groups is known as analysis of variance. Since Professor Padhi allotted me only 1 hour, I will discuss about only two different types of analysis of variances, not more than that. So let's start with the first. Comparison of leukocytes among Indians, Polish and Germans. Is there any impact of region or the country on the leukocyte counts? In the end, it means one-way analysis of variance is an extension of independent t-test, and in independent t-test we have only two independent groups, and in our hypothetical example independent groups are males and females, but instead of these two we can compare in n number of groups, maybe 3, 4, 5, 6 and so on, of n numbers. And our title is, in case of the ones our hypothetical title is comparison of leukocytes among Indians, Polish and Germans. It means this is an extension of independent t-test. As I have said, independent t-test is used to conduct survey studies, comparative survey, one-way analysis of variance. Since one-way analysis of variance is also used to compare more than two groups, so by applying this we also conduct comparative surveys. Next one is repeated measure analysis of variance. Repeated measure analysis of variance. One, as I have said, one-way ANOVA is an extension of independent t-test, and this repeated measure ANOVA is an extension of dependent t-test. What was our example of dependent t-test? Our example of dependent t-test was effect of morning walk on blood pressure. For how much duration you have given treatment? Suppose 3 months of morning walk. It is possible first 1 month may be beneficial, and after that maybe that may become overdose, maybe negative effects. So we require exact date of improvement. So independent t-test only we have two observations, that is pre and post. But in this one repeated measure ANOVA, we compare more than two observations. The title may be trend of the effect of morning walk on blood pressure, trend of the effect. And we may take 3 observations, 4 observations. Suppose we have taken 4 observations in the form of a pre-test, mid-test 1, mid-test 2 and final test. We can compare 4 different observations of the same group. We can compare 5 different observations of the same group, and so on. So this repeated measure ANOVA is a statistical tool which is used to conduct experimental study, especially to find out the trend of the improvement in biomedical researches. That you will find the application of this repeated measure ANOVA, especially in the articles in the research papers which are indexed in Scopus, which are indexed in PubMed, which are indexed in Web of Science. You will find the application of repeated measure ANOVA also. So in the limited duration of time, it is not possible to discuss about all methodologies. Now I will demonstrate few. First, I will demonstrate how to test the normality by using any software, and I will demonstrate by using this SPSS, how to with a hypothetical example. Suppose any investigator want to conduct a study by taking a 20 subjects. How to test the normality? Why we are testing the normality? Why we are going to test the normality? Since we have to decide whether we have to apply parametric or non-parametric. See, I am entering only 20 scores of any variable. Maybe these are hypothetical data, maybe blood pressure. These are hypothetical scores. And I entered 20 scores, and I am giving the name blood pressure. Is it normally distributed? How many methods we have to test the normality? We know that we have 3 methods. Please try to recall. First method is descriptive statistics. In descriptive, how many measures we require? 4. Skewness, standard error skewness, kurtosis, standard error kurtosis. Second method was, we have discussed, QQ plot. A standard line is generated and all the scores should be scattered near to this line. Third one is formal test. This software provides us the facility of 2 different formal tests. KST, Kolmogorov-Smirnov test and Shapirov-Wilk test. Now, go to analyze, go to descriptive statistics, go to explore, and bring this variable that is named as blood pressure into dependent list, and click on plot. See the option, there is an option in front of us, normality plots with test, and continue, and click on OK. The output will be in front of you. See my cursor. See, the value of skewness is minus 0.18 and this is minus 0.14. We both the values are less than their respective standard errors, or we can say that since both the values are less than 1 or in between minus 1 to 1, yes, data is normally distributed. We can apply parametric, and another is QQ plot. See the QQ plot. See QQ plot. In this QQ plot, a standard line is generated. All the scores should be scattered near to this line. In this, all the scores are scattered near this line. So this, since all the scores are scattered near to this generated line, standard line, yes, it is concluded that data is normally distributed and directly we can apply parametric. Next one is formal test. This provides the facility of 2 formal tests, Kolmogorov-Smirnov test, Kolmogorov-Smirnov test and Shapirov-Wilk test. So now, without saving, I am deleting this output and I am making this non-normal exceptional score. So suppose we are having one patient with very high blood pressure, 150 entering, and this only one subject, that is the score is entered at sequence number serial number 7. This distorted whole distribution. Now I am applying the same technique, testing normality. Go to descriptive, go to explore. Okay, you will see the value of skewness, it's 1.97, and see the value of kurtosis, 6.50. It means it's non-normal. And see the QQ plot. See, this score is scattered away from this standard line. On the basis of that, we can say that yes, since the data is non-normal, we cannot apply parametric. metric, we have to apply parallel non-parametric technique. Ladies and gentlemen, this software also provides the facility how to find out the outliers, how to find out this accepted score. We know that we entered this exceptional score at the serial number 7, and see, this is identified by the help of box plot. See the box plot and see this value. It means on 7th serial number, this score is exceptional. So we, as a researcher, first we should eliminate this score, and instead of conducting the study on 20, we should conduct our study by taking only 19 subjects. That will not be considered as unethical issue. Since we are eliminating the score during the screening of the data, now since I eliminated the score, we will not find any outliers. Again, I am repeating: descriptive, explore, and click on OK. See the box plot. Yes, one more, 4th number also, 4th and 17th. These are also outliers. Yes, see, 17th, yes, 98. That is also considered as a, so we can eliminate, we can find out. Otherwise, we have to apply parallel non-parametric technique. So after demonstrating the methodology to test the normality by using SPSS, I will discuss about one more technique, since only we have 4 or 5 minutes. Dr. Padhi assigned me only 45 minutes for this presentation and demonstration purposes. Then for 10 minutes we will discuss. Now we will discuss about the application of independent t-test, which is used to conduct comparative surveys. Suppose if we want to compare the blood pressure of males and females, suppose investigator conducted the study on 20 subjects, 10 males and 10 females. All the scores in SPSS, all the scores are entered in a single column. So I am entering the scores of the blood pressure of males. Now I'm entering the blood pressure scores of the females. First 10 scores are of males and next 10 scores are of females. Now we will give the code or a label. One stands for male and 2 stands for female, and go to the variable view. In the first column, we entered BP, and in the second column, we entered the variable gender, and we conducted this study on both the genders, males and females. Go to values in front of the gender and give the label. 1 stands for males, add the score, and 2 stands for female and add this. Click on OK. Now we will give the command to the software to analyze data by using independent t-test. Data entry is complete. Go to analyze, go to compare means, go to independent sample t-test, bring BP in the test variable, blood pressure in the test variable, and gender in the grouping variable. Define the groups, and we have defined as 1 and 2. Continue, click on OK. See, oh, we have taken 11 females and 10 males. Yes, this technique, it's clear. This technique can be applied in case of equal sample size as well as unequal sample size. We conducted the study by taking unequal sample size consisting of 10 males and 11 females. These are the mean values, standard deviation, standard error of mean. The t-value is 0.113. This t-value cannot be negative. So we have to ignore the sign minus, and this is not significant. It means males and females possesses the same level of blood pressure in layman's language. But ladies and gentlemen, we have this facility in suppose we have taken this 21 subjects and 10 for first 10 for males and then females. I am copying these, and this is the last part of my presentation. We have this facility in Excel also. I am demonstrating by the help of a Microsoft Excel. And in SPSS, we have to enter all the scores in the single column. But in this, we have only one view, that is a variable as well as data view. And this is scores of males give the heading, give the label, and this is females, and all the scores are entered in separate columns, and after 10 I am taking these scores. I am going to paste in wait, I am taking, we have 10 males and 11 females. Yes, I am demonstrating by the help of this Microsoft Excel. Click on data. You see this data analysis is there. Click on data analysis and find out the two samples assuming equal variances. Click on that. Click on OK. There are two ranges, variable 1 range and variable 2 range. In front of the variable 1 range, click on arrow, select all the scores, and again click on the same arrow. Now click on the arrow in front of the second range, select all the scores, and again click on this and opt for labels. Click on OK. The results will be in front of you. Match the results. Output is same as SPSS T value is 0.113. It's not significant. And mean value for male is 85.3, for females 85.63. This facility is available in Excel also. We can analyze data by the help of this software also. So we have discussed about the different techniques. So now the time is over. Now we can, if any individual, any participant have a question, he or she may ask.
Sir, good evening, sir.
Thank you. Thank you very much, sir. On this weekend, there are more than 250 participants attending this session. It's highly appreciating all the participants. That shows the type of interest in the research and learning the statistical concept. So this is just an introductory session, and Dr. Rajiv Chaudhary will be visiting as a resource person for our statistical workshop that we are planning to conduct in PGI in the month of January last week. So and also he will teach some of the concept in future in this weekend webinar also, because today just was an introductory session and we are introduced so many concepts. Each and every concept will be demonstrative using R, Stata as well as SPSS. So friends, if you have any questions, you can unmute yourself, introduce yourself and ask the question. Professor Rajiv Chaudhary will be happy to answer your queries.
Good evening, sir.
Good evening. Good evening.
First of all, a very nice and elaborative lecture, sir. Thank you so much for enlightening us all. I'm Dr. Gopalashi Sharma from IGMC Shimla. And my query is, you have discussed about various tests of normality. Is there any specific test we can apply that this test is more specific for checking the normality or not?
No, we have to use all tests. We have to cross test by using different tests. Suppose if we are conducting the study by taking a moderate sample size, so we have to apply all tests in a sequence. It is advised by the statisticians that first apply formal test, then cross test by remaining two methods.
Okay, sir.
That will be better for us.
Okay, sir. Thank you, sir. Thank you so much.
Sir, thank you, sir. It was very informative session. I have just one question. I have three questions. So my first question is how to treat outliers to make data normal?
How the outliers?
Dr. Ankit, can you please introduce yourself, please, so that
Yes.
Dr. Rajiv will know who you
Yes,
are?
I am Dr. Ankit from Assistant Professor at AIMS Raebareli. And my question is how to treat outliers to make data normal from normal.
How the outliers?
How to treat
Professor Padhi, please repeat the question.
Sir, how to treat the outliers?
Yes, to
Yes,
make
yes.
the data
Like you demonstrated using the QQ plot and the box plot. So
Yes, we can identify the outliers by the box plot, and we may remove if we have only one or two outliers. then we should remove the outliers and make the data normal. That will not be considered as an unethical issue. Otherwise, if we have more than if we have many outliers, that cannot be considered as outliers. It means the distribution is non-normal. In that condition, instead of applying parametric, we have to apply parallel non-parametric technique of. And for example, the parallel non-parametric technique of independent t-test is Mann-Whitney U-test. The parallel non-parametric technique of dependent t-test is Wilcoxon matched paired Sandrank test, and so on.
Okay, my another question is that what kind of regression we can use for a non-normal
What type of?
regression for our non-normal time?
Non-normal. It is very difficult. Regression analysis is not possible in non-normal data.
No,
Since
for example, we have
since we have to test the utility of the established model. Suppose if we want to predict blood pressure on the basis of age, it is essential for any regression the dependent variable should be in usual continuous manner. That way, that can be in interval or ratio scale. And non-normal and in independent variable can be of three types. Maybe in usual continuous manner, maybe dichotomous, maybe categorical.
Okay, sir. Thank you. Just I have one query. How many outliers we can remove? What is the range of the outliers which can be removed? How many outliers we can remove to make the data normal?
There is no standard principle. There is no standard principle. No statistical technique is described or mentioned in the literature. Ki this much count is acceptable or we can remove.
Sir, I have one more question. What is the difference between 1 and 2 tailed tests?
Why?
1 and 2 tailed. 1 tailed, 2 tailed test.
Yes. We should test our value on two tail. It is advised or suggested by the statisticians since there will be less probability of committing the error. The value which is significant at two tail test, two tail, that will be significant and on one tail. This is the main reason behind that.
Okay, sir. Very thank you.
You are correct. It is advised by the statistician. He always test on two tail.
Thank you very much, sir.
Hello, sir. I am MSc.
Hello, sir. Myself, Dr. Sanjeev Mishra, Assistant Professor from Bhimsar, Odisha. I want to ask that in multivariable analysis, in how many variables we should test for the normal distribution, sir? Only the outcome and exposure variable or other variables?
Sir, I will add something. In case of, it is also advised by the statisticians not to use multivariate. Why? There is a cause. In case of univariate, it is very easy to draw inferences and interpret the results. It is very difficult to interpret the results if we are applying multivariate, and you will be agree with my comment. And in relation to the inclusion of the variables, hello,
Yes, sir.
sir, getting my point?
Yes, sir. Yes, sir.
Okay, I think we have not touched this regression today. So in the subsequent sessions, we'll introduce one concept in one class. For example, t-test. We'll dedicate only one session for t-test, one session for chi-square, one session for logistic, and one session for linear regression. So, like that. So that,
Sir, I have seen one question in the message box. It is written that I have said the normal distribution depends on sample size. No, normal distribution is not depend on the sample size. We have to use different methodologies to test the normal distribution in case of small, in case of moderate, and in case of large sample. The concept is this.
Okay,
The
friends,
question is,
anybody has any questions related to t-test or some normality? Because today only we discussed these two concepts. So you can ask on this, and in subsequent sessions we will introduce other concepts.
Hello, sir. I'm from Kanpur. I have
please
done.
provide the reference of classification of sample size into small, moderate, large. You will find several literature. I will suggest from Mridu Shaman Sekia asked a question. References from, if you want any reference from the field of medical sciences, write in any search engine, Google search house, write down Y.H. Chan. Y.H. Chan concept of sample size. You will find Dr. Chan classified into 3 different categories, and he is a great statistician from the field of biomedical researches. Sekia ji, is it okay?
Okay, somebody has one question. Can you please unmute and ask the question, friends?
Hello,
Yes,
sir.
yes.
Sir, I'm from Kanpur. I'm MSc in statistics. So in pure statistics, mathematical. So sir, like what we have learned that from central limit theorem, if sample size is large enough, then independent of any any distribution, we can convert like approximation can be done to normal. So can we use
Yes, please wait. Gentlemen, there is a difference between the pure statistics and the applied statistics. One main point is, and you told about the center limit theorem. There is a concept of the center limit theorem in case of the sample size. Suppose if I ask a question from you, if you repeat the same study 10-20 times, the results will be same or different? I will clarify your question. Suppose if you repeat your study several times, the result will be same or different?
Maybe he has lost the connectivity.
The result will be different. It means, suppose you conduct a study by taking on 1000 population, by taking only 50 sample, and you select randomly, and again you conduct the study by taking again by 50 subjects. If you repeat the same study 10 times, the result will be same, and you calculate the mean value from the same. It means the concept of center limit theorem is the mean of all means will give you a precise result. But gentlemen, this facility is provided, the parallel solution is provided by the confidence intervals. By the help of confidence intervals, we can check the quality of results. That is based on the center limit theorem.
okay, sir. Thank you, sir.
Next one, please unmute yourself and ask the question.
Good evening.
Or raise your hand. I will ask one by one. Okay, so just unmute one. I am not able to see any hands, and
Good evening, sir. Sir, myself, Dr. Arshi Chawla from PGI Chandigarh. Sir, I wanted to ask regarding, you mentioned that in t-test, the negative sign, we have to ignore the sign sometimes, but in dependent pair t-test, the negative sign is indicating that the mean difference between the first group and the second group. So the negative sign can be.
Madam, in all the 3 types of t-test, we have to ignore the sign. That is a defect of the software. Why? There is this is a mean difference. Madam, if I ask a question, mean difference, can a mean difference be in negative? Mean difference means we have to subtract lower from the higher. It's clear.
Yes, sir.
If pre score is higher, then we have to subtract post from pre. If post is higher, then we have to subtract pre from post. The difference between means cannot be negative. The concept is this. And you will not find in pair t-test also, dependent t-test also, that is shown in a positive way.
Okay, sir. Thank you, sir.
Sir, I'm Dr. Ankit from AIMS Library. I have one more question that in SPSS software, I have seen the YouTube video just saying that we have to prefer the Sapro-Wilk test over KS test. So if, for example, if we run the test of normality and we get two different results in two different tests, like KS test saying it is normal and Sapro-Wilk saying is it is not normal. So which test we should rely on?
Yes, sir, your question is very sensitive in nature. This happens when the normality is at borderline. This happens. It means it is very difficult to identify whether it's normal or non-normal. So instead of applying formal tests, QQ plot, application of QQ plot and the calculation of skewness and kurtosis is enough to decide whether it's normally distributed or non-normally distributed. There is no need to apply formal test.
But sir, I have seen many YouTube videos, and they always say that we should rely on Shapro-Wilk over Kolmogorov test.
Yeah, yes, this is an individual difference, but all the three methods are used to test the normality. And in present scenario, we are seeing this formal test. Earlier, all researches have been conducted, and that before the application of the proper statistical tool, all researchers tested the normality by using descriptive statistics only.
Thank you, sir, very much.
Next, anyone?
And it is very difficult to communicate the statistical methodology on online mode, but I tried my level best.
Yes, sir. We
Since it is-
understand. We understand it is very difficult to teach statistics using in online webinars. But I believe those participants are registered for our workshop and they will be benefited in your presence, physical presence.
and Paddy sir, we have discussed about only basic techniques.
Yeah.
Basic.
So, friends, anybody has any question? We have to respect time. So, because I promised everyone 1 hour. So, if anybody has want to ask anything, you can ask. Otherwise, Professor Rajiv has shared his email and phone number also I have shared in the leaflet. So, you can contact Professor Rajiv. For one quick
When the
last question,
sample,
yes, please.
so when the sample size is more than 30, they say that it's not T distribution and we have to use Z test. Can you just comment on this?
Yes, madam, if we study the latest literature in new books, you will not find the application of any jet test. It is advised by the statisticians to apply t-test also in case of large sample.
Okay, sir. Thank you, sir.
Sir, I have one doubt regarding that
Please introduce yourself.
Yeah, I'm Danya, doing MBH in University of Hyderabad. So, sir, doing in moderate testing normality in moderate sample, you said about the cross testing. Can you just mention it once more?
No, madam. In case of moderate or in large sample?
In moderate one, you have said about the
in moderate sample size, we have to cross test the normality, but in case of large sample, there is no need to cross test. Reason behind this is these formal tests are very accurate in case of large sample, since these are structured by considering large sample, but since these tests are very sensitive in case of moderate sample size, so there is a need to cross test by remaining two methods, that is descriptive and QQ plot.
Okay, sir. Thank you very much.
What we understood for the large samples, like for the NFHS data or any WHO survey, so we don't need for testing of normality because they itself considered. But in case of small sample size, like say 30, 100, so we need to first check the normality, then we apply the test.
Good evening, sir.
Sir, please introduce, sir.
Yes, sir. Myself, Dr. Ashok from PJ Chandigarh. Sir, what do you mean by like Welch t-test?
Which t-test, sir?
Welch t-test, Welch.
No, there is no Wells t-test, Wells test. Wells test is there.
Okay, sir. So what do you mean
Wells
by this?
test is, suppose Wells test is related to analysis of variance one-way ANOVA. Sir, I have discussed that normality, if data is normally distributed, in that case we have to apply one-way ANOVA, otherwise we have to apply parallel non-parametric technique that is known as Mann-Whitney test. But one more assumption is also required to apply one-way ANOVA, that homogeneity of variance. If homogeneity of variance is there, then we can apply one-way ANOVA. Otherwise, if this homogeneity of variance assumption is not fulfilled, in that case, we have to apply Welch test.
Thank you, sir. Thank you.
Dr. Ashok, is it clear?
Yes. Thank you, sir.
Sir, I'm Dr. Ankit from AIMS Raebareli. I have one more question. Can we apply one-way ANOVA for non-normal data, or we have some different tests for non-normal data if the sample are?
I reply to Dr. Ashok. It is essential. The data should be normally distributed if you want to apply one-way ANOVA. Otherwise, in case of non-normality, we have to apply parallel non-parametric technique. So, and the parallel non-parametric technique of one-way ANOVA is, sorry, Kroskal-Wallis test.
Yes. Kroskal-Wallis test.
Kroskal-Wallis test.
Thank you, sir.
Good evening, sir. I am Dr. Vishweshwarrao.
Sir.
Hello.
Please. Yes, sir. We are able to hear you. Please.
Yes, sir. Sir, can you test normality using histogram? Histogram.
Yes. You can calculate normality in histogram also. Sure.
Yes.
Why not?
Okay.
By using
Sir,
the
in Excel also can you do, sir? Excel also.
No, I do not have an idea about the Excel. There is no. I don't think Excel has a facility. But in this in SPSS you can calculate. You can draw a histogram. Histogram of all the scores will be converted into standard scores automatically, and the standard scores, and we know that the value of standard scores is in between -3 to 3.
Yes,
and a normal distribution curve will be, and the mean for the in that histogram should be 0, since the mean value of the standard score will be 0 and standard deviation will be 1. That will be displayed in SPSS.
Yes, sir. Yes. Thank you, sir. Thank you.
But I do not have an idea whether Excel is having this facility or not.
Good evening, sir.
Good evening.
Yeah, myself is Dr. Sumit Unadkat. Now, how do we assume that in a normal distribution, standard deviation is 1? Mean, we can take 0, that I understand by taking the difference between observation and the mean of the difference is 0. But how come the standard deviation is 1?
We are not talking about the actual scores. We are talking about the standard scores. Standard scores. There is a difference between the standard scores and the normal original scores.
Okay.
If the data is normally distributed, in that case, the mean of the standard score will be 0, and mean of the standard score, standard deviation of the standard score will be 1.
Okay. Okay. Thank you.
You may put in the formula of the standard score, you will find the value.
Right. Thank you, sir.
Sir, one more question, sir. After doing t-test, we present the data as mean and standard deviation or mean and standard error. Which is appropriate, sir? Mean and standard deviation or mean and standard error of mean? To present as a tables.
In the calculation of t-test, in all the types of t-test, independent t-test, dependent t-test, and one sample t-test, standard error is considered. The formula is,
Yes, sir.
the formula for, suppose if it is if we talk about the formula to calculate independent t-test, so t value by the help of independent t-test, the formula is dm. Dm is difference between mean divided by under root standard 1 square standard deviation 1 square upon n1 plus standard deviation 2 square upon n2. That will be calculated by that, and that is a standard error 1 plus standard error 2, and we know that standard error is calculated by the standard deviation 1
Yes,
upon n1. Is it okay?
Yes, sir. Yes, sir. Yes. Thank you.
Standard error is considered in this.
Yes, sir. Yes. I understand.
So, okay, friends, if you have no question, so the theme of the conference, the webinar was let us understand statistical concept in layman's language. So when I circulated Professor Rajiv Chaudhury's pamphlet for this webinar, many of students or faculty, they surprised how a non-statistician will talk statistics, because he is a physical education faculty of law. So it is a passion. If you learn anything with a passion, everything can be achievable, possible. So many of my friends and students, they fear about statistics. So I promise them, you please attend this weekend webinar session. We'll introduce one small concept, and if you have a passion of learning, then you can learn everything. So friends, let us thank everyone, all attendees, all participants, Professor Rajiv Chaudhury, and the most important is the Department of Telemedicine, PGI Chandigarh. With the support of telemedicine, we are able to host, allow more than 250 participants. One of the time there were 260 plus participants were present. Earlier we used to Google Meet, which allows only 100 participants. So we thank our special thanks to the Department of Telemedicine for providing this facility. And we thank you all the participants and Professor Chaudhury for your valuable time in discussing statistics. Thank you, everyone.
Thank you, sir. Thank you. What is, sir? May I leave?
Yes, sir, you can leave. Thank you, sir. We'll
Thank
see
you.
you in soon PGI Chandigarh in month of January last week.
Thank you, sir. Thank you.